In the previous lesson on autopilot pitch modes, we looked at altitude hold, vertical speed mode, and altitude acquire, which is an automatic mode enunciated on the primary flight display only. During this lesson, we will continue to look at the remaining autopilot pitch modes, including level change and vertical navigation. This time, we will carry out the same climb we did in the previous lesson, using flight level change mode. Starting again from 5,000 feet, select 30,000 feet on the altitude selector. Remember that it not only arms the altitude alerting system, but also initiates the calculation of a climb thrust value by the thrust computer based on the change in altitude. For this example, let us say that we are maintaining level flight and 250 knots using a thrust value of 85% N1, and that the thrust computer has calculated that 95% N1 is the required value for this climb. After selecting 30,000 feet, now press the Flight Level Change button. Flight Level Change mode engages, and Altitude Hold mode disengages, indicated by Flight Level Change Speed being the enunciation in the Pitch Flight Mode Enunciator window. Simultaneously, the auto throttle will change from speed to thrust mode, indicated by N1 or thrust in the Flight Mode Enunciator. The auto throttle will now advance the throttles to give 95% N1. As the thrust increases, the speed would tend to increase, but you can see that the level change button is linked to the speed window of the mode control panel. So to prevent the speed from increasing, the aircraft will pitch up and start to climb. As the aircraft is climbing, the auto throttle maintains a constant value of thrust, and the pitch channel of the autopilot is maintaining the speed by making small adjustments to the pitch attitude. If you look at the pitch window of the flight mode enunciator, it is telling you what it is doing. Flight level change speed. The target speed can be seen at the top of the primary flight display speed tape. When the aircraft reaches 10,000 feet, the speed can be increased by turning the speed selector to 300 knots, and the aircraft will pitch down to cause the speed to increase. The thrust will remain constant. When the aircraft reaches the changeover altitude, where a constant Mach climb is required, the changeover button is pressed, and the speed display will change to Mach 7. As the aircraft approaches the target altitude, the altitude alert system will alert the pilot as before. Shortly afterwards, altitude acquire will engage in pitch, enunciated by altitude acquire replacing flight level change speed. Simultaneously, the auto throttle mode changes from thrust to speed, enunciated by a change from thrust or N1 to speed. As the aircraft levels off, the auto throttle moves the levers rearwards to maintain the selected speed of Mach 7. When the aircraft is level, altitude hold becomes the engaged mode in pitch, and altitude hold will enunciate, replacing altitude acquire. The light in the Alt Hold button will illuminate. Descending using flight level change mode is the reverse of the climb. When an altitude lower than the current altitude is selected in the altitude window, the auto throttle computer will target idle thrust. When the flight level change button is pressed, the throttles drive all the way back to idle, with idle or thrust showing on the flight mode annunciator. The pitch mode will change from altitude hold to flight level change speed, and the pitch channel of the autopilot will pitch the nose down to maintain the mode control panel speed. The speed changes in the descent can be made in the same way as before, using the changeover button to change from Mach to indicated airspeed, and the speed selector to reduce speed as required. Remember that the pitch attitude will change to adjust the speed. Lastly, we will carry out the same climb using the vertical navigation function of the flight management system. As well as the navigation information, the flight management system also holds performance data for the engines and aircraft, and has the ability to provide vertical guidance for the aircraft throughout the whole flight profile. It can provide target values of indicated airspeed, Mach and thrust for optimum control regarding a selected performance mode. For example, economy climb, economy cruise, or long-range cruise. Performance calculations are produced when the flight management system is initialized by entering values of weight, route information, target altitude, and cost index. A cost index is a figure provided by the company which is entered by the flight crew to determine the optimum performance with respect to fuel burn and trip time. The default performance mode is economy, using the minimum fuel for the minimum flight time. The vertical guidance function controls the aircraft vertically within flight plan constraints, producing pitch commands to the flight control computer and thrust commands to the auto throttle. From 5,000 feet, we will select 30,000 feet in the altitude window and then press the vertical navigation button. Vertical navigation engages, shown by the annunciation VNAV speed on the flight mode annunciator. Simultaneously, the auto throttle changes from speed to thrust, annunciated as either N1 or thrust. The speed window of the mode control panel goes blank, or is replaced by 4 dashes, to let the pilot know that the flight management system is now commanding the speed, and there is no longer control of the speed from the mode control panel selector. The target speed is still shown at the top of the speed tape. The auto throttle pushes the levers forward to increase the thrust to the flight management system commanded value, and the pitch channel of the autopilot pitches the aircraft to maintain the target speed. As the aircraft climbs, the speed transition is automatically commanded at 10,000 feet. And an automatic changeover from speed to Mach occurs at the required point. As the aircraft approaches 30,000 feet, the aircraft will carry out the altitude acquire maneuver, but this time it is not annunciated. Instead, the pitch window will change to VNAV path, and the auto throttle will change back to speed. The pitch channel of the autopilot is now maintaining the altitude or vertical path derived from the flight management system. VNAV Alt will be displayed, while vertical navigation is maintaining a mode control panel altitude, if flight towards the vertical navigation profile is constrained by the mode control panel selection. For example, in this case, if the vertical navigation target altitude was 33,000 feet, with the mode control panel selected to 30,000 feet, For vertical navigation to control the descent path, there needs to be a defined end of descent waypoint with an associated altitude constraint. This will allow the Flight Management System computer to calculate the required top of descent point at which it needs to start the descent, so as to be at the correct altitude at the end of descent point. The economy profile is economy descent to 10,000 feet. Then, to reduce speed to 250 knots or below. The change from Mach to indicated airspeed hold during the descent is also automatic. Ideally, the computer will use idle thrust and optimum speed values, but these can be varied to take account of unforeseen wind conditions to keep the aircraft on the correct descent path. To use vertical navigation for the descent, select the descent altitude in the altitude window prior to reaching the top of descent point. The Flight Management System computer will then automatically engage VNAV speed from VNAV path at the top of descent point for the pitch channel, and thrust N1 or idle for the autothrottle. The throttles will move back to idle and allow the aircraft to deaccelerate to the descent speed if lower than the cruise speed. Then the pitch channel of the autopilot will pitch the aircraft down to maintain that speed with idle thrust. Changeover occurs automatically from Mach to indicated airspeed, as does speed reduction at 10,000 feet. At the required altitude, the aircraft will level off as the autothrottle takes back control of the speed, and the pitch channel of the autopilot maintains the altitude. The flight mode annunciator changes autothrottle to speed and pitch to VNAV path. When lateral navigation is used in conjunction with vertical navigation, fully automatic, performance-optimized guidance through a sequence of waypoints is achieved in azimuth, elevation, and velocity. Lateral navigation and vertical navigation can be used separately. During this lesson, you have learned about the remaining pitch modes of level change and vertical navigation.